We should be all good for that.
There. Oh, I didn't.
Now, as you all roll into here, I think we started you out with your microphones open. You can mute them if you want, unless you got something to say.
I'll probably mute mine for now. Do you know how to do that?
Once.
Oh, yeah, right there.
There.
No.
Must rely on kid. You're not alone.
I see the digital divide as a challenge when a kid knows how to do something I don't know how to do. It really motivates me to learn how to do it.
Yeah.
This grid reminds me of that game where you had the Revis and you had to solve it, and they would only reveal certain squares when you. I can't remember the name of that show. That was a long time ago. I guess I'm dating myself.
It sounds like a human Tetris game.
Yeah, exactly. Yeah.
Now, while we kind of roll in here, you guys got your hardware handy, right? Got a microbit nearby and a USB cable, because we're going to be quite hands-on for the next hour 15. Get your workspace comfortable, get those headsets untangled, get your cup of coffee. Grab your snacks. I see some familiar names rolling in here. How nice. We're sitting just under 60, so we'll give it another minute here. It's a pretty high attendance ratio. Good morning, Michelle.
Good morning. How are you?
Great. How are things in Northern California?
Great. I am sitting here looking out my window, listening to the birds outside, and it's a beautiful day.
All right.
Yeah. This is my view. I have to show you.
Let's check it out. Oh, nice. Garden's looking great.
Thank you. It's doing good. I'm battling gophers, so I'm trying to figure out good organic ways to deal with that. But
well,
thank you.
How about a Rodex 3000? Is that organic enough?
Yeah.
You know what those are?
No, but it sounds really awesome.
Well, it's a concussion device, we shall say.
Oh,
with propane and an igniter.
I'm writing a note down on that one.
The old Rodex 3000.
Rodex 3000. We are going to build a barn owl box out there and see. That's not an immediate thing, but see how that goes.
The other solution would be to get a schnauzer.
Okay. I know. I was watching YouTube videos yesterday, and one of them was like, get a schnauzer and train it to hunt gophers. And I thought, oh my gosh.
Oh, but my mom has a schnauzer, and you don't have to train them.
Oh, really?
Yeah. in their blood.
The gophers would be gone, but probably so would all my plants.
And any tubers or bulbs
Yeah.
are coming up too.
All I have is this pug.
Oh, look at that guy. He might be an award winner. That's your
Oh,
coworker.
yeah, he's a thoroughbred. I love this dog.
There we go.
I'm holding her, right?
We'll start in
Good
about
morning.
2 minutes. Good morning. We're
Good
sitting
morning.
just under 70, so allow a couple more to roll in here. I mean,
Big
imagine
flat.
this. 70 teachers, you're all going to be programming at the same time. What could possibly go wrong? This distance learning is really asking for it, isn't it?
Distance learning on steroids today.
It really is. This exercises every possible feature of Zoom and computers and USB ports at once.
And I was thinking, I don't think I've ever been on a Zoom call with 80 people in it. I'm
Yeah.
curious how that works.
Well, I use the meeting format so y'all can go a little bit crazy and chat and talk as much as you need to, because this needs to be interactive.
Awesome.
Well, you know,
Well, should
going
we
back
get
to
this
what-
started?
Can
Hi,
we
Ed.
going
start?
back to what Joel said, with this type of an environment, May the 4th be with us, right?
Ah,
Not that I'm a Star Wars guy, but hey,
What a
More of a
perfect
Spock guy.
well, since you mentioned it,
as always, Ken, right on point.
takes planning. Okay, enough entertainment. Let's start this party. How is everybody today? Shout out, just let me know your audio is working if you want.
Doing good.
Good.
Doing great.
Hi.
Great.
Good, good.
Doing good.
Good.
Oh, that's more like it. Oh, okay, great.
Good.
Okay, so you know how that works. Make sure you know how your mute button works too. Okay, my name is Ken Gracie. I want to welcome you to the Cyberbot Educator Workshop. We're going to be at it for about an hour and 15 minutes with a little break in between. And this is going to be a lot of fun. This is actually the 7th distance learning workshop I've run since middle of March, since the COVID outbreak. And you are teachers number 220 to 280 getting trained. So how about that? Some of you have seen before. Okay, before we really get rolling, a few things here. This is about the Cyberbot, programming in Python, building electronic circuits. So a wonderful product, probably our most popular robot at the moment, uses the microbit. And your hosts. My name is Ken again. I'm from Parallax, and I've been working in educational robots for over 20 years. I have my preliminary CTE credential in California. I've not finalized it because work has had the best of me, but I've spent about 7 years in class. And I have a lot of respect for you teachers, because while I might know the content material, communicating like a teacher is a whole nother story. So I got to hand it to you. I could hardly handle the schedule getting to school on time. My co-host, I have several people here from the Cyber Innovation Center. Kevin Knowlton, are you online by chance?
Hey, Ken, I am online.
Oh, welcome. Maybe you can introduce NYSERC.
Fantastic. Happy to do so. NYSERC, the National Integrated Cyber Education Research Center. We're a nonprofit organization that has a federal grant to develop cybersecurity curriculum. And you know what, Ken? It's crazy. We have to give it away for free. So all the content in the curriculum that you'll see kind of demonstrated today, all around the Cyberbot, we have available. So nicerc.org. And the folks on the call, Chuck, Tommy, Joe, I think they are going to be able to speak a little bit more to the content during breakout sessions and things of that nature. So it's great to be partnered with Parallax in this endeavor. Ken and I go way back many years, and as a great friend, and together we're doing some pretty incredible things for cybersecurity education across the country.
Thanks so much, Kevin. And it should be noted too that this whole training is made possible by Kevin's team and NYSERC. So they actually sponsor these robots for you. Thank you, Kevin. And thumbs up from everybody online. Yeah. Okay, cool. Also from NYSERC, we have, he mentioned 4 people on board here today. One of them being himself. So the other 3 are Tommy Gober, Joe McAdam, and Chuck Gardner. And Tommy, I've elected as my co-pilot to keep me straight during this because it gets kind of crazy. And then Joe and Chuck will run breakout rooms when we have technical difficulty. So in doing these previous to now, we developed a little more skill at where to peg the meter. Some people complained it moved too slowly, and for others it moved too fast. Sounds like a classroom, right? So the way we're going to handle that is we'll take a side stream branch and open up breakout rooms when we need them. And then if you're having trouble with any of the technical hurdles, we'll put you in that breakout room, Tommy or I will, and then Joe or Chuck can help you, and then you can come and go from the breakout room. And if you feel like you missed anything, you can watch this video on YouTube later today. So it does move kind of fast. We're taking what would be an 8 or 12 hour or even a 3-day training and putting it into 3 1-hour, 15-minute workshops. So, but we found that it works quite well, and truthfully, I think we all sort of prefer this model going forward. It's a little bit easier, there's no travel, we feel more effective, and we could do more for the teachers from our desks. But it remains to be seen. Pardon?
More bang for the buck.
It is exactly that, yes, from a business perspective, and then it remains to be seen when you resume normal operations in school, whether or not, you know, this will still be a useful model for you, but we'll be watching and working with you. So if you don't know Parallax, we're located in Rockland, California, hence the time zone confusion and some of the emails from several of you this morning at 5 a.m., 6 a.m. saying, hey, where is it? That's okay. We're in Northern California. We're an American manufacturer. We've been at it for 30 years, and we love what we do. All of you, so find your pin. You're from all over the place. Really, you are all American residents though, and spread along the eastern seaboard, the western, couple up north. Texas is a big area. We also asked you a few questions when you registered. What are you using? And here's what you told us. So a whole variety of stuff, which is good. Many of you have tools in your class, 3D printers, laser cutters, hand tools, etc. And just as a verification, you are seeing my screen, right?
Yes.
Okay.
Yes.
The green outline had disappeared. So sometimes Zoom does some funny stuff.
No, we're looking at your face.
Oh, but you aren't seeing the slideshow.
Oh, yes, I am. I'm sorry. It's on the left.
Okay. Good. Let me just make sure that that's all good. Yeah, as I mentioned, the outline disappears. So sometimes you don't know really what Zoom is doing. Tech tools, yeah, you have a variety of tools, computer controlled tools. Most of you are using Windows and a number of Chromebooks and some Macs too. Most of you are high school teachers. There are some community college, and a few middle school, and some down to 6th grade and 5th grade. We do see this being used down to that level. It just totally depends on the teacher's tenacity, interest, and the student level, and all those things you know about. And then just in the notes that you submitted back to us, you're very appreciative for the class. Thank you. And your students are interested in this content. This we know to be true for sure. And they're also interested in cybersecurity, which is a big part of the CyberBot. And by the way, it's the 1-year anniversary. So we've had these in the wild now for just over a year, and the reception is quite good. We're very, very pleased with it. So let's talk about the agenda for today, and then we'll just jump right in. If you've opened up this Google presentation, you've probably perused this a bit, but basically divide this into 3 days. And I tried to hold you back from getting started too much on your own because I wanted to give you some robot building tips and talk about servo centering live in person before you actually do it, because as an educator, if you end up using this in class, you're going to do a lot of these things. I want to be sure your skills with it are, your skills and your comfort levels very sharp. So today we'll just introduce the Cyberbot briefly. We're going to connect right away the microbit to the Python editor, write a couple scripts, and then learn how to use the Python editor and how to save programs, edit them, increase screen size, all this stuff. And we'll jump into adding the robotics module, which is called the Cyberbot module, to the microbit. And at that point, we will use some of our educational resources. We'll calibrate servos. And then after today, you could build your robot between today and Wednesday. That takes about an hour and a half or so. Then on Wednesday, we're going to focus on driving the robot around, and we'll get a bit more into Python. So one of the goals here is to have a good tool to teach Python, but getting there is a little bit of work, but it's exactly the kind of work that your students want to do. So you will lure them right in here. And on Wednesday, some of our action will really begin as we drive the robot around and look at many ways to make it do different things using more Python. And then we'll build our first circuit together, and you'll go away and build more of an advanced circuit on your own. And then on Friday, we'll demonstrate it, talk about those circuits, and then we're going to get into the cybersecurity stuff, which is really cool. If you follow any of our social media, you may have seen some of the videos last couple of weeks where we are controlling 30 robots at once from a single computer. And we will show students with our tutorials how to lock those robots down using key shifts and encryption to control them. And this is a great basic overview of cybersecurity without the complexities of, pre-programmed computers and, software licenses and all that. We could just demonstrate it at a real low level, which is where this begins, foundational material. And then we'll have our award ceremony for you. Have fun. I'm sure by now you've sat through enough Zoom meetings where sometimes you even act interested and you tune out when you need to. I think you'll like this one though. And we welcome your feedback. Unlike listening to, say, like your chief learning officer, your supervisor, you could tell us what you think as we go, and we will adjust, because our goal 100% is to serve you with this. I want you to participate and learn about the resources, and then identify the challenges. So as I step back, and I've done this now for a lot of years, I know what the difficulties are of using robots in classroom, and we're going to take those difficulties very much head on and go through them. And they actually have little to do with the educational content that you're trying to teach, but they're real issues with using any hardware in life, any electronics, microcontrollers, robots. And there's a small list of them, and we'll encounter them and get stuck and then get on through them, because your students will have the same trouble times 20 or 30. So you will demonstrate something, and then they will all ask you how to do it. Is that how it goes?
Wait, what?
Yeah, wait, what? All right, so you could read that list. But basically through this, we'll gain confidence, and we want you to build and program your robot so that when you go back to class, you can demonstrate this in front of them. And I want to answer your questions too, whatever they are. You can shout them out, you can type them out. Tommy is watching the chat, but you could just enable your mic and say whatever you want. So no students online, no confidentiality. Say what you think.
And Ken, I also wanted to mention to everyone, take no offense if I'm going through and militantly muting everyone's mics. Just trying to keep down the chaos.
Yeah, and everyone has this control too over your own mic. That's why we're using the meeting format. So we have award ceremony on Friday. We have 3 categories, not 4 as stated here. The first one is the funniest animal or coworker. So anything from babies to pets to colleagues, spouses, whatever. The second category is the biggest fail, and these are all self-proclaimed. You have to submit your entries through the week. The awards are big, I'll tell you that. And then the third category is the biggest winner. So just to look at some of the things we got last time, all right? We saw a lot of Python snakes, and I bet there are at least 5 of you that have Pythons, right? Well, we're gonna have to step it up because all the Pythons have been shown. So this will not qualify for the funniest coworker or animal award. This one was pretty good. This was a good fail, and until you build your robot, this won't be entirely appreciated, but we had one user that just couldn't figure out why the servos were not getting signals. Went over and over and over, and we said, you're gonna have to show us your hardware. And we looked at this, and then we quickly figured it out. So for the first class, the board was totally upside down. That's the microbit is the little black module. It should be mounted underneath the board so those gold contacts can touch the springs on the bottom of the Cyberbot board. So you got to be willing to tell on yourself and make fun of yourself, okay, to win this one. And then here was one of our, we had 4 biggest winners, and this one I just really liked because it combined several circuits. It integrated the infrared, so the wireless ability to detect objects on the sides, and then the whiskers. So if it didn't see it, it could touch it. All right, who's down for winning an award this week? All right, yeah, what will that award be? I don't know. I mean, it might be something like this, a gripper. I know, oh, big dollar, CNC machine in America. Who wants one of those?
Yeah.
Oh, I know, it's amazing. Or a line follower kit. Or it might even be something like this.
I actually have the line follower kit. We won our robotic competition with it.
Oh, all right. Good. So if I didn't already mention it, discussion is welcome and appreciated. We are on schedule. You don't have to worry about having all these links handy yet. We will introduce them to you as needed, but these are in the presentation, which we'll also provide to you as a link. And these are pretty much the resources you need to run a class with the Cyberbot. And I should say, I don't think you have to do a whole lot of work to do this. The material's there. It's very well evolved and it's mature, and there are a lot of jumping in and jumping out points you can pick and choose from this stuff. So we'll come back to that as we start to use it. And then finally, before we really get underway here, I assure you all, you're running the class that your students will remember. All I remember from middle school was programming on a Timex Sinclair 100 computer and then being terrified of the dances. And then of high school, primarily it was a stained glass class. So hands-on activities are what your students want so bad. It's one chance when they're in charge of their learning. And I'm certain it's what they'll remember. By the way, this kid, you can go watch him on YouTube. He did a review of the Cyberbot. And at the last USA Science and Engineering Festival, he would not leave my booth for 2 days. And I've encountered so many students like this, like you all have. And this is what you talk about when you discuss what you like about teaching. Sitting in an office, we don't get it, but kids like this, I often meet them when they're young, and then we support them all the way through, you know, college at this point because we've been around for so long. There's also a previously recorded webinar you could watch that I'll send you a link to in case you want to see this from a different perspective. So Python and robots, this is an ultimate combination, I think, because students can see their program run and you can do in-class competitions, and it's pretty much got everything, mechanical, electronics, coding, and a lot of problem solving mixed into one. It's one of these things, yep.
Can you program the thing using a iPad?
Mm-mm.
No?
No, because, yeah, the iPad is the one tool that most developers of hardware, educational hardware like this have avoided because it's just too complex to deal with their API and too locked down.
Yeah, I'm not a big Apple fan, but
I will, again, I will jump in and say,
yeah,
for the microbit, you can use the iPad to program it. You're greatly restricted on what you can do with that. For example, you cannot put that microbit on the Cyberbot and then do all the cool activities we're going to do today. You can just interact with just the microbit itself. So yeah, it's Bluetooth that's on here, and there's an app that will allow you to do that, but it's mostly just drag and drop block-based programming, and it's kind of restricted.
Cool. Yeah, I'm glad the Chromebook went out over the iPad. In the beginning there, we were trying to support both, and we were just losing on both fronts, but Chromebook made it easier. So who's familiar with the microbit? Just thumbs up if you are, maybe. Okay. Thumbs down. Okay. All right. All right. So some are, yeah, some are not. Okay. So what it is, it's a little controller. It was put out by the British Broadcast Corporation. It was really a follow-up to a project they'd done back in the 80s with the Acorn computer, where they put a computer in every class. And this time they came out and they decided to create this little module so every student can program. It's a low-cost module. It's packed with a bunch of sensors and abilities. One of them that I really like is a Bluetooth radio. So it's low cost. It can be programmed in JavaScript, Python, block code. Anything else, Tommy?
JavaScript, block code, or bake code, Scratch 3 supports it, and there is even some Arduino C++ based content that I have not played with that one yet.
Wow, okay. Yeah, and the reason we like it is because Python, in fact, Tommy, this whole Cyberbot project, this is your idea, right?
Oh, I don't take the blame for it now.
So where is the microbit mostly used? So on its own, it has a fair amount of capability. It can control a motor, it has LEDs, but it's not terribly capable for robotic applications unless you're just doing motor on-off type things with limited sensing ability. So you'll see it often in elementary school and in middle school using like simple kinds of art type projects to make things go or to measure something. It's quite good at that and it's easy to use. So a lot of us will start out, if we use this in elementary, using the block coding, which looks like this. And we aren't going to do this today, but y'all can go there on your own afterwards. And it's pretty fun.
And Ken, as you're just kind of scrolling through some of those, the block-based stuff, if you're wanting to do block-based content in the classroom, that's where you can use some of the NYSERC content. We've got elementary and junior high specialists that have put together lessons using the block-based coding. My colleagues that are doing that are a little apprehensive about doing the Python side of things, but they're happy to guide you through lessons on doing that. And that's all, again, that's all free.
I want you to have that handy and bring it up in a while to show it, okay?
You bet.
So Python, a lot of times we get asked, why Python? Well, Python right now is just tremendously popular. I grew up programming in BASIC, and the reason I love it is because it reads very simply. I've programmed in BASIC, Pascal, Fortran, and a variety of languages. C I tried, failed miserably at C. But Python I really like. So it reminds me of kind of where I've been. It's just easy. By the way, Python was developed by Vito Guanrusum, a Dutch programmer who went away at Christmas time in 1993, I think, for 2 weeks and emerged with this language, which is now Python is eating the world. So
Named after Monty Python, isn't it?
I think so, yeah.
Yep.
In short, and you will learn this by doing it. I like to learn by doing. I'm the one person that gets that IKEA furniture and tries to build it without the instructions first. But yeah, which is a mistake in that case. But we don't want to talk about this too much, but here's some of the highlights. It's super beginner friendly, it's object oriented, and it runs on embedded hardware. So we don't have to be stuck on a screen forever. There are tons of examples. There's really good programming tool support, and it forces pretty much syntax following and indentation, and it's just easy to read. So that's what I like about it. Now, how are we getting it on a microcontroller? Okay, so we have these little micro bits. So Python is a large library language with tons of capability to run on a PC. There was an open source project just a few years back by this guy, an Aussie named Damien George, who we've been communicating with. And Damien started a Kickstarter and produced what is called MicroPython. So he took what is useful out of Python to run on microcontrollers, and then he made several ports for it that would run on limited resource hardware. So you have less RAM, you have less memory on these devices, and so you don't want to clog up your system with tons of things you don't need. So what you see in MicroPython is everything you need to run on an embedded controller. So some of the stuff on here, it's loaded up. The LEDs are really fun. They can be used as light sensors. There's digital and analog I/O. There are a couple buttons. There's a Bluetooth radio. And Tommy mentioned programming with the Bluetooth radio, but what I like it for is the cybersecurity stuff. So just microbit to microbit type communication. Reset button, battery connector, accelerometer, magnetometer, a compass, and you can hook up earbuds, play music. There's all kinds of stuff here to work with.
An ADC built into it.
ADC, yep, and it runs on pretty much whatever you guys have got. So before we look at the educational resources, and there's plenty here, we're actually just going to get you set up. So everybody grab your USB cable and connect your microbit up to your computer if you've not already done so, because we are going to program. Oh, there's a temperature sensor too. Yeah, thanks for pointing that out. Okay, so as you do that, the next thing we're going to do is open up Python's web-based browser. And the address for that is python.microbit.org/v/2.0. So maybe you can all open that up. You'll see I'm computer problems already. We expected that.
Could you please type that out?
Yeah, it's hard to see. Okay.
I'm on it.
I'll actually put it in the comments of the source code that's shown on the screen. I think you'll be able to see it here. How's that?
And also this very first program will pop up whenever you open the Python browser.
Yeah, so you'll lose that link that you're looking at. Yeah, so we're doing well so far. It's only 8:30 on the West Coast.
Yay.
I see a few people are tangled up with their USB cable still. So one thing, while we just get fully navigated to this tool, this is great because this is a web-based interface, okay? So your IT guys at school are not needed to get you going here. Yeah, I imagine that's the saving, right? So all you have to do is have a computer that can read basically what looks like a USB thumb drive, okay? Because that's how the microbit will be recognized by your computer. And a browser, of course. And we prefer Chrome when doing all of this. Yeah, so the difference between this and other tools are no drivers to install, no downloads, and every time you go here, you get the latest version of the tool because it's cloud-based. Now, there is a caveat to that. Your microbit, and I know not all of you received all of my emails. For whatever reason, some schools tend to block, and I don't know, maybe I had some email addresses were not right, but there are a handful of you here that probably didn't get our email. But one of the things I asked you to do was to update your microbit firmware. And just give me a thumbs up if you got that message. Okay, cool. Did y'all do it? All right. Okay. So having done that, you have an option here to download code directly to your microbit, which is much faster than the alternative. So what happened is, and this is often the case with hardware gets released and then it will be out of sync with the software. So in this case, an upgrade was made to the microbit online editor, and then the software for the microbit followed, or what we call the firmware. Okay, so I just got a request to show again how to how to get to the Python editor. So we'll do that one more time. So the path is, I will copy it into my source code for those still trying to get here.
It's in the chat also.
Okay, cool. Thanks, in the chat. Okay. All right, and I also got some feedback on the video getting a little bit wonky, so hopefully that doesn't become a problem. All right, so we discussed how to upgrade firmware, and that is something you need to do to use this tool efficiently. So if I just go into Google and I type in how to upgrade microbit firmware, you will encounter videos and then a web page on how to do it. And it's quite easy. You just download a file from their site, and then you press the button on your microbit and you drag it onto the microbit, which looks like a hard drive. Then you release the button, and then it's upgraded. So what that will enable you to do is the following way of flashing code. If you follow my screen for a moment, you'll see, and my microbit firmware has been upgraded. I'll demonstrate this first and then show you the longer way to do things if you've not upgraded your microbit firmware. So on the upper left, you'll see the download and connect buttons. You have to first connect in order to directly flash the device. So when you click connect, you'll see this window come up. Python editor wants to connect the BBC microbit, and then it says paired. And that does not mean paired as in Bluetooth. That means it's physically detected through the USB cable. So select it and then click connect. Once you do this, oh, okay, I might have what is an old microbit. So it's a good learning moment. I'll just get a different one. Yeah, isn't it though? So
I totally had this planned, everyone.
I did, yeah. So I switched microbits. So half of them will see what I just saw. So I have a microbit that has firmware upgraded. So I'm going to select it and click connect. Now after I do that, the download button became flash. All right, so there's a little change that happened. This means that the Python tool and your microbit are in sync and everything is updated on your microbit. It has the firmware. So now you can flash. So with one button, you press flash and you'll see this window flashing microbit. And then your first program will run. Okay, so if you were unable to connect, then you would see this. The first button would be download and then connect. Okay, so in this case, we have to save a hex file and then we will drag it onto the microbit drive. All right, so you can follow me here. And you can do this as well if you'd like to, even if you were able to flash. So if you click on load save, and then you can scroll down a little bit. In my case, I'm zoomed in kind of heavy here. Download project hex. And we always want to work with this button, not with the Python script button, okay? The difference is that the Python script button just gets your text file, your source code, and then the download project hex gets any modules that you'd included. Am I right on that, Tommy?
Yeah, you're right on the Python script. It's just text. You can open that with Notepad. You can edit it, manipulate it however you want. The hex file you could think of as a compiled, quote unquote, compiled block of code. It's in a digestible format for the microbit. If you try to give the Python text file to the microbit, it doesn't know what to do with it. You go to hex file, it goes, oh, I know this, and it will run it.
Okay, so I'm going to download that and save it to my desktop. All right. So now I've put that hex file on my desktop. Now I will go show my desktop, find the microbit in a Explorer window. And just to verify, Tommy, you can still see my Windows Explorer window?
Yep.
Okay. All right. And then I'll find the microbit program and I will drag it onto the microbit. And then it will run. Okay, so if you update your firmware, you won't have to go through this process.
Oh, couldn't do it.
Okay, so let's see, maybe by a thumbs up or thumbs down. Give me a thumbs up if you were able to connect and flash. Okay. All right. And give me a thumbs down if you were not able to connect in Flash and drag and drop was your only solution. Huh. All right. And of those with the thumbs down, did you also update your firmware?
I'm trying to update the firmware, and it says error. Could not find valid MicroPython UICR data.
Okay, I haven't heard of that one before.
I tried to drag it into the black area of the microbit online programming.
Okay, so I'm wondering if we should make a breakout room. Let me ask a third question then. Of all of you, were any totally unable to get the program on the microbit by flashing it or saving a hex file? If you were totally unable to get the code onto it, give me a thumbs down. Okay, I see one. All right, so Tommy, let's make a breakout room.
All right.
And then I think you can actually do this.
No, it's not giving me the breakout room option.
Yeah, it disappeared on mine as well.
Super.
Go figure. Yeah, how about that? Just verify that one more time as I poke around. Oh, okay. So, Tommy, if you could, while I look for breakout rooms, could you go over the chat? Walter made an important note here.
Yeah, good point, Walter. So those of you that are having some issues with the uploading, to flash the firmware on the back side, I'm gonna pin my video up here real quick. Spotlight it. So on the back side of your microbit, there's a amber light that is shining whenever it is connected. That is going to rapidly flash as data is being transferred. That's the first thing to know. When you are sending any data, so you're sending your hex file over to your microbit, that amber light is going to blink. As Walter pointed out, whenever you go to do that reset on that link that Ken told us about, and I think if you scroll up in the chat a little bit, it's on the that link is on there. You'll need to press and hold that reset button as you are connecting that cable. So you're pressing and holding the reset button as the cable is going in. And then when you let off of that, instead of the normal flash drive appearing that is named microbit, it's going to come up with the name, I forgot what it's called, and it didn't do it on mine when I did that.
It's called maintenance, Tommy.
Maintenance.
Yeah. Maintenance, there it is. Okay, so whenever you do that and it has maintenance, that's when you know that it's ready to receive the firmware update. So look for maintenance. If you're not seeing maintenance, when you're trying to perform maintenance, just know that you need to hold that reset button on the back side there.
Okay, so I did make 2 breakout rooms. I made one called Joe and one called Chuck. So at this point, I would say let's use the chat. If you have trouble, just say that you need to go to a breakout room, and then Tommy will move you over to one of those. So you can just type a message in chat. Don't send it privately. Just send it to everyone. Just say trouble. Yeah, I need breakout room. And then Tommy, what you can do is click on their name and then assign them to a room. Let me know if you could do that. Thanks for everybody's patience. This is all part of the fun. It's just one of the hurdles on the way. We'll get through it.
Actually, Ken, it's not letting me.
Okay, not letting you assign.
I can put him in a waiting room, but that's not what we want.
Okay, let's see here. All right, if you give me some names, and there are 80 here, so this might be difficult for me to find them all.
So I'll try and give them to you a little bit in alphabetical. Adam.
Yeah, ready to go. Okay, just a minute here. Okay, it's not going to work the way I wanted it to, because on the participant list, I cannot assign them. So I have to find their pictures, and their pictures are out of order.
Oh boy, okay.
So Let me just give it one more look. Yeah, we did not get to test breakout rooms with 80 of you, so we'll give it a minute here poking around. Okay, what we could do, since we're going to have a little bit of trouble using getting everybody in the breakout rooms, I think we'll just go over this again and see how many more we can capture. Does that sound good?
Yeah.
Okay. All right. So I'll walk you through this again. All right. So on my computer now, if you go back to my screen, I'm in the Python online editor, and I've put the path here in case you've had trouble getting there. And once you go here and hit refresh, this program will come up. So there are two ways of getting the program downloaded to the microbit. And I'm going to show you the preferred way if you've upgraded your firmware. So you'll see the download button and the connect button. And you first have to connect. Once you've connected your microbit to the online editor, then you can actually flash the firmware. This download button will change to flash. So to do that, click on connect. And because I've already connected, I did not get the window come up that says pair this device, but you'll see a little window that lists your microbit. Click on the microbit and then click connect. After you do that, this download button becomes a flash button. And now I can press that and then directly download to the microbit from here with no further action. So if you don't have that ability to connect, it's because your firmware is likely outdated, and there's a process for updating it. I'll post it in the chat right now. And it would be fine if you went over here and just did this for a while. Takes like 5 minutes. So I'm posting it now. There it is. You can follow that link and it'll take you to this page. And the process is just scroll down to download the latest firmware, which is 250. Oh, actually, no, it's 253. I'm sorry. So you hit that black button and then you will follow this process shown in the video. Okay, so if you don't want to upgrade your firmware or can't or whatever, then you could do this. So this assumes I don't have firmware which has been updated. You can click on download, and this will make a hex file, okay? And you can pick where to save it. If you can't pick, then it's going to your default download directory that's set by your browser. Okay, it might be downloads. In my browser, I've set my downloads target to be my desktop. So I'll put it on my desktop, and the name of the program in my case is microbit program 1 hex, because it's the second time I've saved the same program. All right, and by the way, that name is right here. It's the script name. So I've saved that hex to my desktop. Now I'm going to go to my desktop, and I'm going to open up a Windows Explorer or whatever it is, Mac Finder, desktop, and then you'll see that your microbit shows up as a hard drive under your computer. Okay, so once you're there, you can go get that hex file you made and you can drag it onto the microbit. And it will load it and run it.
I think I have a dead microbit.
Totally possible, yeah. So if you're in that category, we'll sort that out afterwards and get you a live microbit.
Thank you.
Things do happen. I mean, so with 80 of you, and this is really why Parallax is a company, you know, to do things right, we service situations like this all the time. If you're missing a screw, if you're missing a microbit, we'll make it right. So don't worry about that. Logistics is half of our game. All right, so for those of you that had trouble, since we had breakout room trouble, we will just extend this a little bit afterwards and try to keep you going, try to fix your problems. We'll move on now. So I want to talk a little bit about this editor. Okay, the first thing is the name of your program is up here, script name. So if I just call this example, and then I go to save the program, and there are a couple ways you can save it. You could download a hex, or you can click on load save. I'm going to use the load save button and then choose download hex. You'll see that it saves it. And in my case, I had Chrome set up to prompt me for a destination for that file. So I choose desktop. So how do you configure Chrome to do this? I found this is a stumbling block for a lot of people. Everything goes in downloads by default. So if you go into Chrome settings, this is what you're using. Okay, and someone note in the chat, Tommy, you can just read that while I get here.
The
Firefox.
Yeah, so actually, Robert's the one that reminded me of this. So we are using Chrome for this. Chrome and Firefox work best for this. I'm saying that as politely and tactfully as possible, meaning other browsers don't generally work well with this. Hint, hint. So use Chrome or Firefox for these. And that has a lot to do with the way that those two browsers handle the web interface, web hardware interface. Personally, I use Chrome, Ken as well. We're using Chrome on these. So if you can.
Use Chrome if you have a choice.
Yeah.
All right, so how to set the download directory location. In Chrome, if you click on the little dots on the far right side and then choose settings, and then once in here, you'll see this window, and then choose download. So it's not save as, but it's really download is where it's located. You'll get the download settings, and you can choose this button here. Ask where to save each file before downloading. Okay, this will help you tremendously. If there's a place you want to keep all of your downloads for your code that you generate, go into Chrome, settings, type download, and then check yes on ask to where to save each file before downloading. All right, what else is in here? So there's control plus and minus if you want to zoom in. And as you zoom in, the text gets bigger and the button labels go away. Keep that in mind. And there are many other things that we'll explore as we use them. So for now, just try something simple. Change the text. And download another code. You can also change the sleep value, make it something shorter, and copy and paste your code if you want, just to see that you can actually download code. That's the goal at this moment. So I'll give you just a minute there. And while you do that, I am going to post a link to the presentation I am using here. And I'd like you all to be able just to grab it and get a copy offline so that after our session today, you can go run the many programs that we've produced. And I'll send this to you by email. So if you don't get it, it's no big deal. So did we get some successful edits out there of the code and download? Give me thumbs up, yeah? Okay, good. All right.
If having issues, please over in the chat, let me know. We'll try and get you squared away.
Yeah, absolutely.
Joe or Chuck.
Yeah, so there is a huge list of available images, and it's in the BBC Microbit Python documentation. In fact, I'll give you those resources after class today, and I'll show you really what is in this microbit import. So this microbit import module includes everything you need to use Python on the microbit and modules and classes for all of the hardware that's on the microbit, which leads us to where we're headed in just a minute here, which is adding the CyberBot module. Okay, so let's first introduce the syntax here and see what happens. This is very important. In doing this, I'd like to advise you not to mix tabs and spaces with Python. So use tabs or spaces. Here's another trick. in regards to tabs and spaces. If you watch my window for a moment, I can select multiple lines of code, and then I can tab them in together to indent. This is very useful in a block indenting type of language. So you don't have to do one line at a time. You can do several. I'd like to introduce a syntax error. So I'm going to capitalize the W in while true. And then I'm going to download it to the microbit. I'm going to flash it, and you will see what happens is we get a syntax error on the microbit. And it's this really cryptic way of solving problems. It says line 4. I can't really see it. Syntax error line 4, something like that. Okay, so it doesn't tell you what the error is, but tells you where it is. If you don't want to wait for your microbit to scroll through this and try to decipher what it's telling you, you can click on Open Serial, and then you can reset through this button, the microbit, or hit Control-C. I take that back, use Control-C, and it will tell you what the error is and where it is. So again, the way I got there, I flashed the code, so it was in the microbit, it's running. Then I clicked on Open Serial, and then I clicked Control-C and Control-D, and it reset. And it says File, Main, line 4, invalid syntax. So now I can go to line 4. And I could see that, there's something wrong. And this can cost you a lot of time, but it'll direct you to the right place. So another way to see syntax errors. Okay, so we're at the point now where we need to download the CyberBot module and then put it onto the microbit and center servos. And we're running about 10, 12 minutes behind, so follow carefully. Okay, this is how you do it. You will go to learn.parallax.com, and to speed things, I will post this link in the chat for you. And you will choose CyberBot and then add modules to your microbit. Now here comes the link in the chat. Okay, so you can click on that link in chat and you will open up this window where I appear right now. And as you scroll through this, you will see instructions on how to add the CyberBot module to your microbit. Okay, so it's all very, very well documented if you need to come back here. However, we're just going to do this together. So I will shortcut through these instructions and get you over this. So right near the top, there's a green box that says CyberBot Library Archive. Thumbs up if you see that. You guys are right there. Okay. And for the thumbs down, whoops. Any questions before I go on? Just put them in chat. Okay, so I'm going to click on that, and it's going to take me over to the Parallax site. And we have prior versions. You will obviously select the most recent one. Okay, so when you pick that and download it, save it to somewhere where you can get to it. I'm putting it on my desktop. And it will save as cyberbot-micropython-v080.zip. Okay, and if you're on a Chromebook, this process is slightly different. Okay, then you'll go to wherever you saved it and then unzip it. In Windows, right-click, extract all. Okay, a little bit of a process, but this is just a reality of using, microcontrollers and libraries and code found on the internet. We all got to be able to do this kind of thing. And sometimes it's challenging in Windows because when you click on it, it looks like you're extracting it, but you're really just viewing the contents of it. So I've unzipped it on my desktop, Now I want to go back into the Python editor and I want to add it to the microbit. I want to add the CyberBot module. So I'm going to just wipe out, by the way, the program that's here, just by deleting it, clearing my screen. So to add the module, click on Load Save, third button over in the Python editor. Okay, and we're going to browse for a file. It's the first box up top. It's a hyperlink. It says browse for a file. Click on that, and then you will see a open dialog box, and you will navigate yourself to the unzipped CyberBot MicroPython set of code that you just downloaded. And you should see what I'm looking at. So inside the zip that you have are all the examples used in the tutorials. So you know, you can opt to have students type them or not, but they're all here in the examples folder. So you want to click on cyberbot.py. Okay, this is the code library that enables all of the robot functions. After you click on it, choose Open. And then you'll see a message like I see, and it says, the CyberBot module has been added to the file system. And I'm going to click OK. Now this is tricky part, so don't be afraid to tell me you didn't see any of that, or we'll do it again. Now, how do I know it's there? I know it's there by clicking on the Load Save button again, and then as I scroll down, it says Show Files, and it says 2 now. And as I drop down that button, one of them is cyberbot.py. So that module is now on my microbit.
Hey, Ken, would you mind just kind of going through the steps one more time?
Absolutely, yeah, I'd love to. Yeah, so the process is like this. If you're a student and you're going through our tutorials, you would get to this page, and here's how I got there. I go to
on that
Yeah, how'd
link,
you get to that
you would
page?
go to the show how the loading modules.
Yep. Yeah, okay, we'll do that again. So I go to learn.parallax.com, and this is a link that I put in the chat. I clicked on CyberBot, and we are doing this. Add modules to your microbit. This page comes up, and the first link here is the CyberBot library archive. This is where the CyberBot module lives. When I click on it, it goes to a download page on the Parallax site. And I will download the first one on top, CyberBot MicroPython v080. Click on it and save it. I'm going to save it to my desktop. Again, for you, it might be a little different because I've configured Chrome to prompt me for a save as location. So I have the zip. It's on my desktop. Now I want to unzip it. So I'll just double click on it and unzip it. Okay, I got the zip. It's on my computer. It's unzipped. Now I'm going to go back into the Python editor, and I want to add that module to the microbit. Third button over is Load Save. Click on it. And then you'll see in the top in the gray window, drag and drop a hex or PY file in here to open it. So yes, you can arrange windows side by side, drag it and drop it, but I'm going to browse for it. So I browse for it and I go to the unzipped folder, click on cyberbot.py, then click Open. You'll get a message. In my case now, do you want to replace the CyberBot module? I'm going to say OK. So how do I know it's there? I know it's there by clicking again on Load Save and then scrolling down, and under Project Files it says Show Files, and there are two of them. The cyberbot.py file is now shown on the microbit. Okay, so now we have access to everything in that library for the robot, and we're going to put it to use. So maybe thumbs up here. Are we doing okay?
Ken, do we have
Yep.
to do this every time, or we
No.
just do it once and it's always there?
Yeah, Kurt, it's a good question. No, one time and it's there. Yeah, but it does, things are a little crazy, will disappear from time to time. We're taking hardware, software, let's say microbit from one place, software, open source project, and robots from Parallax. 3 different suppliers come together. Things will occasionally go wrong. Okay, so once you've got it there, we can actually move into, okay, so if you have trouble, just keep using the chat, and I think Tommy is trying to sort those out with you. Let's move into now actually centering the servos so that you could build your robot between today and tomorrow or Wednesday. So I'm going to turn my camera on. There are 2 aspects to this. One is setting up the board with the servo, and then the other aspect is writing code to control the servo. And the reason we're doing this a little bit differently than the tutorials is there are 2 ways to install the servos on the robot. I'll demonstrate here. Switching my camera over to the document cam. Okay, zoom, bring my cameras back. Thank you. Okay. As you notice when you look at a servo, side view here, it has a spline, which is, we'll call it the motor, the drive shaft, where you'll connect a wheel, and it is offset. It's not in the middle of the case. All right, so when you install these motors on your robot, you have 2 ways of doing it. You can do it with the wheels forward, or with the wheels more centered towards the middle of the robot. Okay, I like to install them with the wheels more centered towards the middle of the robot. And the reason I do that is it turns better on a variety of surfaces. With the servo switched over and the wheels forward, there's more drag on the tail wheel, and on linoleum it could stick. So this also makes a tighter turn radius. Now when you do this, you do not have access as easily to the potentiometer. There's a little, what we call potentiometer in the servo case that you will adjust to center the servos. It's right here. So the battery pack is providing a little bit of a physical interference. However, if we center the servos before we assemble the robot, then you can build the robot this way. Otherwise, you're free to center the servos after you build the robot, and the potentiometer will be on this side, which is clearly accessible by a parallax screwdriver. Okay, so I just like it this way because a robot makes a much nicer build, it looks cooler, and it navigates better. So the system you need now is the following. Yep.
Ken, can you stop sharing your screen so we can see this bigger?
Oh yeah, thank you.
Thanks.
And so I think you mean Spotlight.
People can also pin you if you click on Ken's little tiny tile on the right. You can hit pin, and his video will take up the whole screen on the computer.
Okay, so yeah, just click on me, then you should be able to get the large video. All right, so you're all seeing the video that I'm looking at right now, which has the Cyberbot board and a servo and a battery pack. All right, so how do we attach this? What we need to do first is attach the microbit to the Cyberbot board. So there are a couple parts. I'm just going to take mine apart really quick. And you can gather up the pieces to do this right now. And those parts, which I sent you in an email, consist of 2 440 flathead screws, that's a flathead screw, all right, 2 of those, 2 of these black acorn nuts, and then 2 nylon machine nuts, I guess we'd call those. And the assembly goes together as follows. So we want to take the microbit module, and the LEDs will always be up so that they are facing you, the robot programmer. You can put these 2 flathead screws through the 2 outer holes and then tighten them with these nylon nuts. And this whole assembly will self-center itself so that the pins of the microbit line up properly on the CyberBot board. And I hand tighten those, but you can use the little plastic hex key wrench that we have in the kit.
You can show us a side view of that real quick. I was able to get the screen sharing off so folks can see that. Back it up just a little bit. Your camera's not quite focused. There we go. So we've got the screw going from the bottom, going toward the button side. And then you use that nylon nut to hold those on place. You do those on holes 1 and then the hole that's labeled ground.
I'm new with the stock cam too, so I don't know how to quite
back it up some.
Is that okay?
There, that's a little bit better. There we go. Starting to get focused a little bit. I think it probably has like a 6 or 8 inch focal length.
All right, I go to there.
There, that's much better.
Okay.
Hole 0, you're right. Thank you, Kelsey.
Yeah, hole 0, and then what is the ground hole? Okay, so once you've got that, you can take your board. Just gonna unplug all the stuff that's on mine. And you'll attach it. So you'll connect it right underneath. And those springs will provide you some kind of resistance, so you'll just hold it there. Then take those 2 acorn nuts.
And Kim, before you tighten that all the way down, it's worth noting too that the edge of the microbit has those little gold contacts on there, and we're lining those up with the contacts that are on the bottom side of the CyberBot board. That's where the communications happen, and so that's what we're lining up. And if you put the screws in those in hole 0, thank you, Kelsey, and hole ground, that's going to line up and everything's going to work well. You just need to make sure that your microbit is on the bottom side of the CyberBot board. You should see the Parallax and NYSERC logos on the top side.
All right, success so far. Give me a visual confirmation from those out there. Okay, cool. Thanks for your patience. I know this is challenging doing this online, but hey, it's a new way and we're doing great. You know, we are, roughly an hour 10 into this, and this is kind of where we get at hour 2 in a live class with humans face to face. So tighten up those acorn nuts and then let's connect it in center servos. And I hope you're all okay with time. We're running a little bit later. We could go as late as 9:30. So let us know if that's a problem for you or not. Okay, so my microbit is connected to my CyberBot board. Now I want to get the battery pack. And maybe you've got your battery pack handy from my prior email, maybe not. You need 5 AA batteries, and I'm just going to plug it in. Like so. And then I have these 2 servo motors. Servo 1. And servo 2. We're going to center the servos. So we're going to be writing some code that will send a signal to them that will hold them in position, which is the middle point. So when you tell the robot to stop, it stops. So the first thing we got to do is plug these servos into the CyberBot board. You'll notice the servo has a white, red, and a black lead. Okay, so I want you to grab one of them, and then the white lead will go closest to the silk screen on the board that says P18. So you don't want to reverse them. And you can plug them both in. One goes in P18, one goes into P19. And these are I/O pins that we will point to in our Python script to control the servo. So I'm plugging both of mine in. Questions on this?
On ground.
Yeah, the black is ground. And then you'll see off to the side of where they plug in, B, which means black, R is red, W is white, black is ground, and then red is 5 volts. Okay, there's also a little jumper next to where they connect right here. And that jumper could be either on what's called VIN or VDD. And by factory, from our shop, it should come on VDD, which means 5 volts. You can run it the other way too. It just means you're going to get the direct battery input voltage.
And if you
Okay,
don't
so
know what that means, it's okay.
yeah, I'm throwing around some big words here. You can call us on it. Okay, so I'm connected. Are you connected?
That's not so good.
Okay. This is a first-time experience for some of us, and others have worked with all kinds of microcontrollers, so we'll be all over the map here. It's okay. All right, so I'm happy with what I see. I got a battery pack in, I got the microbit connected to the Cyberbot board, and I've got 2 servos connected to the Cyberbot board. So I'm going to switch over now to my Python editor.
In just a second, Ken, let's give some folks a moment to get caught up here.
Okay. This will be our break
Not without the
time.
magic smoke. That's a great success. If you guys don't know what that is, inside every electronic device is some magic smoke. That's how they work. If the magic smoke comes out, they stop working. So never let the magic smoke out of your electronics.
Don't plug capacitors into the outlet.
Bly is asking, what model servos are you using, Ken?
I'm using parallax continuous rotation. These are actually a custom-made Futaba S148 servo, made in Japan.
Can you zoom in on the servo connectors? I don't know if the zoom, if we'll be able to get much detail on that.
Okay, we'll try.
We can try though.
Okay, we're going to use the manual zoom.
There we go. So
Does that help you? By Wednesday, I'll have this doc cam totally figured out. You know how it goes. You go to Amazon and all the document cameras were $300. So I just search high and low. Yeah.
That's your problem, man. I'm telling you.
Did I spend too much?
No. Our friend Mark Spencer loves the IPvo, but you also know Mark Spencer, so.
Well, I found it for $90 after I looked for a while.
Oh, okay.
Just to back a question.
Yeah.
Just to back up a bit, could you show the orientation of the 440 flathead screws and the washers on the microbit board? Just a side view of that.
Oh, okay. So now it's going to be tricky because it's assembled.
That's okay. That's okay. Okay.
Does that help you?
Yeah, that does. I've got it. Thank you.
Yeah, and I don't mind spending time on this at all because students will do all kinds of wonky stuff. There are also metal machine nuts in the kit, and they will try to use those in place of nylon, which will cause a short.
So you're using one end, the head of the 440 screw to make electrical contact on the mic side that you're showing there, and then the insulator acts as a spacer. That 440 nut acts as a spacer between the two boards. Is that correct?
Yeah, actually, the screw is not doing a ground connection. We get that from some of these other pins. So it's just doing a physical connection, but it is on the ground. I think it is on the ground pads. Well, one of them is P0, but it's okay because it's not connected to anything with the screw.
Oh, okay. Thank you.
Sure. Yeah, all good questions. Got to build it right. Okay. Getting back to the Python editor. And now let's get some code. Then we'll talk about centering servos and we'll actually just do it. So by the way, everything I just showed you, we just jumped you through assembling your robot, adding a module to it. So you haven't built it yet, but you'll be ready to build it.
Again, before you click into that, scroll up just a moment. I want to highlight these for folks. Add modules to your microbit. That's where we downloaded the CyberBot, the zip file that contains the py file. That's in the add modules to your microbit. Right next door to it is where we saw the directions on how to, convert to a CyberBot. Convert to a CyberBot shows us how to put those screws in the holes, align it to the board, get it connected there, and that moves us to where we're at now. So those are the two kind of key information modules that we've covered so far.
Yeah, and we haven't gone into these tutorials at all, but there are over 100 pages of material here, and they're organized by prerequisites, main lessons, and projects. But I'll leave that up to you to look at. We will use them on Wednesday. So, okay, back to the Python editor. Let's write some code now that can center the servos, and I'll show you how to do that. This is another one of those things we have to be able to do well because it will pose various problems in class if not done properly.
And do you have to have your microcontroller connected to your computer at this moment?
Yeah, thanks, you do.
So we've got the servos connected, we've got the battery pack connected, the microbit is plugged into the CyberBot board. Everything is still, like the microbit is still running the code that we gave it earlier. So when you plug in your USB cable and it has some power running to it now, you will see that scrolling message that we had. And Ken, we're getting some other questions on the screen that you're at right now where you've kind of got this blacked out screen. Earlier we had the hello world. How did you get from the hello world to the blanked out screen that you see now?
I just selected the code and hit delete.
So we just deleted all the code that we've got.
Yep.
You also gave it a name up the top right corner. You have example up there. That again is going to be the name of, it's some kind of descriptive name for what you're doing. Whenever
I'm going to
you
call it
download
servo
the
centering
file, it's going to take on that name.
Okay, so I have a clean Python program. I'm in the editor, and instead of saying from microbit import star, we can now say from CyberBot import star. All right, now we will show you what the contents of CyberBot module is on Wednesday, or you can read about it between now and then. But it includes everything that's in microbit, plus includes the bot library. And so the bot library is referenced this way by the command bot and then the IO pin, and I'm going to use pin 18. And I'm going to set the servo speed to 0. And then I'm going to copy and paste it for pin 19.
Yes, we've got a question. What position, we've got a 3-position switch on that CyberBot board. Which position is the switch in? Right now, position 0 at the very moment.
Okay, so once you've got your code looking like mine, you can flash it, and then your motors will probably start turning just a little bit if everything is correct. Oh, and what Tommy said is we will put the switch in position 2 now. Okay, so the difference between 0, 1, and 2 is 0 is everything is off, but the microbit is still powered by USB. Position 1 is everything around the breadboard is powered, but not the motors. Okay, and then position 3, which Tommy always calls more on, since it's more on than position 1, powers up the motors.
Position 0 is off, position 1 is on, position 2 is more on.
Thank you. Okay, so be sure you're more on here. In position 2, flash your code. Okay, my servos now are turning like this. And I think if you just want to maximize my video for a minute, zoom in on it, I'll show you how to center them. Okay, so we've been offering this exact setup with these motors for over 20 years. It works reliably if you can demonstrate to students how to center motors. So inside the motor is a little plastic potentiometer. And you can see it. It's yellow and it has a blue casing around it. It's a pretty gentle part, all right? And turning it even just like an eighth of an inch or an eighth of a rotation will center the servo. So you'll notice when you go one direction, and you can be very light on your screwdriver here, use the Phillips side, it turns one way, turn your screwdriver a little bit the other way, servo rotates the other direction. What you want to do is turn the servo gently until, turn the screwdriver gently until the motor stops turning. And you can actually feel the motor vibrating, that it is getting the signal to turn. So this one is now centered. So then I'll do the second one. Put the servo into the potentiometer and just give it a gentle turn. And you'll feel, the screwdriver. I don't know why I keep saying that. So just put the screwdriver into the pot, turn it a little bit till the motor stops. Those are centered.
Ken, I turned off your screen sharing so that we could see that process. Once you get that stopped and then centered there, would you mind sharing your code screen again with us?
Yep.
I turned that one off. It's my mistake.
No problem. Code screen is shared.
Oh, here's 18.
And a couple of items to note here on the code screen. So you told us to do bot 18.servo_speed value 0. Why number 18 and why number 19? What are those? Where's that connected from? Where's that coming from?
So if you look at the top right side of your Cyberbot board, you'll see what are little white labels. We call these silk screen labels, and it says P16, P17, P18, and P19. Those are the pins that we will use to control the motors, and the white is the signal. Yeah.
Right up there is a little tiny 18, 19.
Is that a better view?
Yeah, we're not gonna be able to see the text on there, but if we look at our boards, we'll see that same just up there at the top of the board there. It says P16, P17. Next to it says P18 and P19. You'll have to look at your board, but it's right there above where the servos are connected.
Tommy, we're looking at code again.
Okay, so we have to spotlight my video.
Mind if I eat my hummus in front of you?
No.
So what you need to do is go to my video and then click on it. Or I could do something if that's a little bit difficult. Here's one other way.
Good. What's your class?
Okay, Zoom won't let me access the camera through Microsoft's tool, but I think several of you told me that you can click on the video and make it dominant in the screen. So if you could do that, please do. Yeah, you're right, Kelsey. It's super sensitive, small movements, and it's a tactile thing. It's like being a surgeon. You have to feel when you're touching it just right. But then your servo will stop. Who had success centering their servos? Okay, good. Yeah, so direction doesn't matter, exactly what Kurt said. You just want them stopped with this signal.
How'd you get the Cyberbot code there from Cyberbot import?
I just typed it, and the module is on the microbit now.
Oh, okay. Thank you.
It's worth explaining here what we're doing. On Ken's code screen, he has bot 18, again, bot 18.servo speed 0 and bot 19 servo speed 0. What that code is doing is it's telling the Cyberbot board, the microbit is what we're programming. It is telling the Cyberbot board, I want to send a speed of 0 to the servos. How fast is 0? That's stop. So we're telling these servos, I want you to stop. But then what we're having to do physically, so we got these electrical signals going to the servos, but what we're doing physically is we're using our screwdriver to train the servos, if you will, to tell them, okay, physically, this is what it means for you to stop. When I tell you electronically to stop, I want you to physically stop. And and you're doing that little set screw in there, that potentiometer, you're training the servos in a way to physically stop right there at that sweet spot in the middle. If we send the speed a positive or a negative direction, then that's going to turn clockwise or counterclockwise.
And here's a picture that should help too. This is a graph of servo RPM versus the signal you are giving it. And so you'll see when you give it a 0 signal, it has 0 RPM. But actually what's happening behind the scenes is, and this is extrapolated, I guess, for the student, but it's the microcontroller is sending a 1500 microsecond pulse every 20 milliseconds to control the servo. So although we just wrote 2 lines of code, that servo signal is being maintained. So the servo is being driven until we change it. So you can see here with different speeds that we might give the motor, we'll also get different RPMs. So just to do a very quick demonstration of that, if you change your speeds after you've centered, okay, and to let's say 50 and then 25, and you flash the code, now you'll see them turning at 2 different speeds. I can make that a little more obvious, maybe by making the 2510. Okay, so there's a relationship between the speed you give it and the RPM. 0 is the middle, minus 200 and plus 200 is the full range.
And I have a question.
Yep.
So when we flash it, that's when the CyberBot library gets imported onto the microbit, right?
Right. Oh, actually, the library is already there. Now we're able to use the library.
So the library is already.
Yeah, you added it here. So if you go under load save, and you remember you browsed for it, you added it, and you'll see under show files, there are 2 files. One of them is the name of your program, and then the other one is cyberbot.py.
But the reason I asked the question is, if you have another microbit controller, you have to import that on there, on that one, or is it already there?
That's correct. Yeah. So for every robot project you do here with the CyberBot, you'll add this module to it. Yeah. So the hurdles you've crossed today are getting your microbit connected to the editor, down flashing code, adding a library, and centering servos. Okay, and now if you flashed, let's just answer a few questions and then we'll talk about homework for a moment. Okay, if you flashed and you did not get any movement, then something is wrong. And it might be just the way you're connected. You want to make sure of the following. First, is your switch in position 2?
So Kim, we were joking about that, but we didn't really explain what the 3 position switches do. So position 0 is off the board, is no longer receiving power. Position 1 means I want the brains operating. I want to be connected to the breadboard area, which we're not discussing today, but that's that little white block area. And that's position 1. Position 2 gives power to the white block area where we're going to be building circuits later on. And it gives, most importantly, it gives power to the servo motors. That's position 2. So right now, we just need to focus on position 0 is off, position 2 gives power to the servos.
Yeah, so use position 2. So in the case of Daryl, if you didn't see, okay, so the problem was position 2 wasn't on Daryl's computer, so on Daryl's microbit. Do you have that working now, Daryl? Let us know.
Also, Lorena had to duck out, but we're going to get the video file and all the supporting links and stuff sent out to you guys later on as well.
Okay, cool. So Daryl, so Daryl's issue was that he was not in position 2. So the common mistakes here are the following. Batteries may be dead, power supply may not be connected, switch may not be in position 2, should be in position 2, servos may be plugged in reversed. The white lead on the servo has to be closest to the label on the circuit board, which says P18, P19. And sometimes people will unintentionally shift the plugs over one post. and then only connecting 2 out of the 3 connections to the wrong ports. So all that has to be working for you to center servos. Okay. All right, so let's wrap it up briefly here. Talk about what to do next.
And also,
All right,
Ken,
so,
I want to make
yep.
available, if anybody has any lingering questions, we'll be happy to stick around after we finish as well.
Yeah, likewise, I will too. And for those that are feeling good so far, this is where you're headed next. Between today and Wednesday, you could build your CyberBot. And the way you will find those tutorials are to go to learn.parallax.com and then click on the CyberBot. Now, remember, the whole purpose of centering the servos in advance was that you could build your CyberBot with your motors oriented so that the servo shaft or spline or drivetrain, whatever you want to call it, is closer to the battery pack. All right, so we show you how to build them the reverse way. But other than that, you can just follow this tutorial, build it, assemble your chassis. You'll find all these parts. If you don't have any parts, send me an email right away. Maybe we can get them to you. And then on Wednesday, we are going to be driving our robots around, getting straight into some of this Python programming. We'll talk about servo signals a little bit more, how to make the robot move, how to make it go a certain distance, speeds, times, and how to ramp speed, how to use loops, nested loops, how to use functions with arguments. This is a lot of fun. Ramping speed, and then to do a predetermined path, and then we'll conclude on Wednesday with a circuit build. So we'll be busy on Wednesday as well. Any questions ending today? You're all doing really well as far as I could tell.
A couple of things.
Yeah.
What would help me, I'm a mechatronics instructor, and I have people with all learning differences. What would help me is, prior to getting some of these things, say, go into your kit and pick up this board. Oh, here, I'll put on video so you can see me too. Go into the kit and pick up this board, and then get feedback if everybody's had, you know, if everybody's ready to go, because I've been trying to keep up with you. I understand what you're saying, but by the time I pull out hardware, get it set up and stuff, you're on to something else, and I've missed what's going on. What I'm missing to is the how to load in the software properly. So I'm going to be hanging on for some help there. But if you could give a moment heads up for people to orient themselves with what they need to connect things up. Otherwise, you're great. I really appreciate all the good work you're doing and everything with this, and helping us get us going. I know it's difficult on Zoom. Zoom's a killer.
You bet. Yeah, we'll do that. So when we grab parts out on next time, we'll be really careful to give plenty of advance notice and say where we're going. Yeah, because I agree. Once we're there, we're already there, huh?
It could be part of my setup too. I'm fumbling on a 3x5 table with a laptop, 2 monitors, and all this hardware, and a keyboard.
Yeah, it's pretty challenging for sure. And we are condensing things here and like hitting the real high points, the gotchas, you know. So
I appreciate it. Thank you.
Yeah, we're getting the frustration, taking it head on. So in your question, Ken, about starting up the software tool, what specifically is your question?
I went through and I had a cockpit problem earlier. I didn't realize that once one connected and it comes up with that connect dialog box, that you have to highlight something and then say connect. And I missed that, and that threw me way off. I finally caught up, and then I tried to download the Servo program, and I don't understand how to do that.
Oh, okay. So, yeah. So once we just typed this in from CyberBot import, you did that, and then you connected and you flashed, right?
Yeah.
And so click connect.
let me do, and that's what I had to do is highlight that. So connect and then go ahead and flash. Okay.
Your flash button should be enabled. Now, you might get a syntax error if your Cyberbot module is not on the microbit.
Oh, it's all on there and ready to go. Thank you.
Okay, then yeah, you're set. And in time, you'll be breezing through these buttons.
And
Yeah.
do we need to do load that library on the other microbit controller that we have?
Let me think about that. Oh, for the cybersecurity stuff? No, not initially. Well, there are two parts to the cybersecurity. One part does not use the robots, but uses microbit to microbit communication, and you will not need this module, but you will need the radio module. So there's another one you'll put on it. Good question. More questions like that. Move into the support side of things here.
Hey, Ken, do you have some homework for everyone to do?
Yeah,
What's
the
our
homework.
goal?
Yeah, build the robot before Wednesday, and I'll send it out by email as well.
Okay, and those directions.
I'll give them a link.
Go ahead.
Yeah, I'll provide a link to them.
Okay, yeah, that's all on that Learn Parallax site. So we'll see that. If you do not have any support questions, I think we're done for the day.
Yeah, we do, unless others have support issues.
We'll be hanging around if you have anything, but thanks for hanging out, everyone. We will see you Wednesday morning with your assembled robots. If you need any assistance on that, we'll be sending that out via email as well.
Can we still get some more help here?
Yeah,
Okay.
I'm going to stay, Ken.
If you don't need help, you're free to go. Thanks, guys.
Yeah, I'm going to hang on. I need help.
Can I ask one question? It's not exactly about help, but it's a follow-up to the second email you guys sent us.
Sure, Vince.
It said, that you're going to expand. There was going to be 500 teachers, and there was going to be 4 more sessions.
Mm-hmm.
Are they repeats of this session so that we wouldn't take them, or are they like part 2, a little bit more advanced, really focusing on the cybersecurity part?
Yeah, great question. So they will be repeat of this, and they'll be run by Parallax or NYSERC, who's with us today. And that goes June, July, and August. And then in the fall, we'll start session 2, more advanced material.
Okay, so there will be something about, a little bit more about the security, because I think I would really like to use this to work some into my class where I actually talk about cybersecurity.
Yeah, so in the meantime, what you can do, Vince, is go to learn.parallax.com. Most of our material I'd say the starter material is posted, and our objective here is to have it all done by June 30th. If you click on Cyberbot tutorials, or just look at my screen for the moment, I'll tell you what pertains to cybersecurity at this moment. Are you looking at my screen?
Yes, sir.
Okay, perfect. So these 3 tutorials are the prerequisites. Give them a look. Computer microbit talk, dictionary primer, and then exception handling primer. So these show you how to send and receive information to the microbit, and then how to use dictionaries, which is a Python functionality that we use heavily to send data over the Bluetooth radios, and then exception handling, which is what to do when the data is not what you expect. All right, so you could look at those 3 tutorials and then scroll down to the main lessons and then check out these 2, cybersecurity, radio basics, and radio data. So you could read ahead and see where we're going. We start by demonstrating microbit to microbit communication openly, and then we add some encryption channel IDs to lock it down, and then we do it with robots.
Okay.
I'd like to know what you think of the material too. We've put quite a bit of energy into it, and it still is being formed up.
Excellent. Yeah, I'm really looking forward. I love to incorporate physical computing into my computer science classes wherever I do it, wherever I can. And this seems like maybe a very interesting way to do the cybersecurity part. Really looking forward to that.
Yeah, it's what I'd call low level. So it's at the root without a lot of abstraction. How do you send data? What's a string? How to encrypt it? It's good basic stuff, versus I think a lot of the cybersecurity programs are more how do we use software and configure software and configure routers. So this is a low level. If you were interested in using hardware to teach security, this is a great way to do it. Or if you've ever heard of DEF CON, which is the big hacking show that's in Vegas every year, that's all about hardware and security.
Okay.
Yeah.
Thank you very much.
More questions like that or tech questions?
So Ken, are you
Yep.
there?
Yep.
I posted up where I was doing fine. I had everything up and running. My microbit was running everything. And then all of a sudden I went to center the servos and I was downloading the CyberBot zip file, but I'm on Mac, so it doesn't zip it. So when I had to highlight all of that and download it, now it says my microbit doesn't have the right firmware. So I can't.
Okay.
Do I go back?
Firmware is a separate issue from the CyberBot library. Did you update your firmware before we got started?
Yeah, I did.
Oh, you did?
Fine. Yes.
Huh. And as you click on your, let me show you how to see what firmware version is in it. So I'm going into Windows Explorer. You can go into Finder, and I'm clicking on details.txt, and this.
Yeah, I learned how to do all that. That's not
Oh.
the problem. It's just that when I downloaded or tried to download that file for your CyberBot library, it didn't download quite the way you guys did because I was on a Mac.
Question. Ken, I jump in real quick. Ivy, so I'm on a Mac too, and let me just ask, when you had the cyberbot.py file, did you load it into the online editor or did you try and drag it onto the microbit?
Good question. I think I went in